Good day, everyone, wherever you are. From the poll, from the vote, from the poll I put on the community, it is popular demand that I solve Cambridge IGCSE Physics, Paper 2 multiple choice, Paper 2-1 specifically, May, June. So, first and foremost, we need to understand how Cambridge IGCSE Physics works, how your grade will be gotten. First and foremost, we should know that Cambridge IGCSE Physics has three components. It's actually 5 components, but you can only take 3 components. We have component paper 1, paper 2, paper 3, paper 4, 5, and 6. Oh, actually 6 components. So paper 1 and paper 2 are multiple choice questions, contains multiple choice questions. Paper 3 and 4 are theory questions. Then paper 5 and 6 test your knowledge of the practical. So usually if you are doing extended, you are going to take paper 2, 4, 5 in some schools. That is, you are going to carry out the practical itself. You set up apparatus and you're going to do the practical. But in some other school, you can do alternative to practical, which is paper 6. So in this class or in this video, I am going to be attending to paper 2-1, May, June 2023. So I'd like you to pay attention. I am not just going to solve the whole paper, but I will explain every question and explain why some answers are wrong and why a particular answer is correct or most suitable answer for that particular question. So I want you to patiently pay attention as I'll be explaining concepts to be understood to answer each of the questions in this paper correctly. Thank you. Let's make a start. Question 1. Which vector diagram correctly shows the force Z as the resultant of forces X and Y? Then I have these options. I need to quickly remind you parallelogram laws of vectors. So looking at this, I need to be thinking in this direction. If I have vector X and vector Y, if I'm going to use parallelogram laws of vector, the resultant will come from the point of intersection of the two vectors. So it means if I complete the parallelogram, the point of intersection of the two vectors, that's my resultant vector. So this is the resultant vector. That is parallelogram law. But if you are going to use triangular law or other law, we are going to use a rule we call head to tail or tail to head. Head to tail. What does this mean? This implies that the head of a vector will be the tail of the other vector. For instance, look at this now. this particular one is never head to tail. Why? The two vectors are going in different direction. For head to tail, they are going to be going in the same direction. The end of one arrow will be the beginning of another arrow, and that's that. But the only thing that will not change there is the direction of the resultant force gotten from parallelogram law vector. So what am I saying? Looking at this is going this way, it's pointing this way, and this is pointing this way. This is not correct. This is not representation of a vector. So Z is not the resultant. These two goes the same way. It can't be. If we are going to take resultant, it has to come from here, not that way. So this is also wrong. Now look at this. This look like it. You can see the arrow goes like this. Yeah. This is the head of this arrow, and there's the tail of this new vector y. The head of vector x is the tail of vector y. Fantastic. But there is a problem. This is pointing downward. And from the resultant vector, from parallelogram law, the arrow should be pointing what? Upward. And so this is also wrong. So if you look at this has the arrow, the end, this is the head of x, and then this is the tail of y, and the head goes this way. Then the resultant points in this direction. So D is the correct answer. Do you understand that? So if you have any comment or you want more clarification, you can drop your comment in the comments section, or you can contact me directly on this email. Okay, Solomon Olusegun at gmail.com. So you can also reach me for personal tutoring on this email. That's very important. You can keep the email, it will be there. So that's why we have the answer there to be D. So let's go to question 2. I'm rubbing off this so I can go to question 2. So question 2. An object falls towards the surface of the earth. The object is falling at its terminal velocity. Underline the word terminal velocity. So which statement is correct? Before we answer this question, we need to take note of important statement there. An object is falling on earth. So falling on earth. Now we need to understand what terminal velocity is. Terminal velocity is that constant velocity of a falling object, when the resultant force on the object is 0. So take note of important things there. It has to be a constant velocity, or you can say constant speed, when resultant force must be 0. So let's talk about the forces acting on a falling object. Please, I'm going to clean up this so that I can have space. So this object is falling under gravity because it's on the earth and there's gravity on earth, so gravity is pushing it down, causing it to be accelerating. So at the start of the fall, this object is accelerating. I believe when I say accelerating, you know that the speed of that object is increasing per second. Because we are not told that air resistance is not present, we should know that it's falling through air, so there will be a force of opposition, which we are going to call air resistance. So this is gravity. Another name for gravity is weight. So, and there is air resistance acting in opposite direction, opposing gravity. Now, as the speed increases, the air resistance too increases. So, invariably, there will be decreasing acceleration. The acceleration will be decreasing. Take note, there is difference between deceleration and decreasing acceleration. Decreasing acceleration implies that the object is still increasing its speed, but not as much as it was in the beginning. For instance, let's say it starts with a speed of 20 meters per second. Then after 1 second is 25 meters per second. Then after 2 seconds, it is 23 meters per second, 28 meters per second, sorry. This is at 0 second, at 1 second, at 2 seconds. Then 3 seconds now, I have 30 meters per second. If you calculate acceleration here, you see that it is 5 meters per second square. The speed is still increasing. If you calculate the acceleration in the second phase, it is 20. Let me make this okay. It is 3 meters per second. It is 3 meters per second square. Then when you calculate acceleration in the third section, it is 2 meters per second square. Note something here. This is the initial acceleration. What has happened? The acceleration keep decreasing. And that is what happens in the case of a falling object under gravity. So, as the air resistance increases, so the acceleration is also what? Decreasing. Until it gets to a point where air resistance, take it as RS, will be equals to gravity. At this point, resultant force, that means if gravity is 200 Newton, air resistance is also what? 200 Newton. Since they act in opposite direction, resultant force is equals to 0. And when resultant force is equals to 0 Newton, it implies that there is no acceleration. So if the body is falling under gravity, we know that it's falling on earth, we know that air resistance is present. So that makes option C and D wrong already, because they said there is no air resistance. That is wrong. So our answer now is between A and B. So how do we now get it? A says there is resistance, there is air resistance, and the acceleration of the object is negative. Well, there is no negative acceleration here. Negative acceleration will only happen if air resistance is greater than gravity, and that means that the body is decelerating. But in this case, there is air resistance And there is no acceleration. Acceleration is zero because resultant force is zero. You remember, resultant force is equals to mass times acceleration. So if it's zero, it's either the mass is zero or acceleration is zero. And we know the body has a mass. So the acceleration is automatically what? Zero. So the correct answer here is B. I want to believe this explanation is helping us, so in case we come across other questions that relates to this concept. So let's continue. Let's move on. Yes, we continue to question 3. So, the graph represents the motion of a vehicle. What is the distance traveled by the vehicle in 400 seconds? Okay, this is a speed time graph with the speed on the vertical axis and the time on the horizontal axis. We know that this kind of graph can give us two information, or we can get two information from this graph, can be derived from this graph. Well, 3, if we want to look at, we can get the speed at any point from this graph, and we can get the time from this same graph. But more importantly, this graph, we can use this graph to get our acceleration. And how do we get acceleration from this graph? The slope of the graph. The slope or gradient, you call it slope or gradient of the graph. The second thing we can calculate here is the distance covered. Distance covered. And to do that, for a speed time graph, to get the distance covered, we are going to consider area under the graph, the shape of the graph, the shape of the area under the graph. So looking at this line, this is the area, this is the distance covered. What shape is this? This is a triangle. So the distance covered is the area of the triangle. Area of the triangle. Let me draw a triangle. So let me rub off this so it does not take so much space. So is the area of the triangle. So we can move on from there. What's the area of a triangle? That's half base times what? Height. So this gives us what? Half multiplied by the base is 400 multiplied by the height, which is 20. So this here gives me 200 times that's 4,000 meters, and our answer here is C. I know a lot of students will make mistake of picking 800, just say distance times time. Please do not do that. Use the area under the graph. Thank you. Or you use average speed times time. That's actually how to calculate distance. Except if it was stated that the speed is constant. And if that will happen, you are going to see that there won't be any change. You are going to have something like this. That means the speed is not changing. So the speed in meters per second and the time. So it's going to form a rectangle. That's the time you are going to use. If you use area under the graph, it's going to be length times what? Breadth. Or you just say speed times time. Please take note of that. Okay? Let's move on. So question 4 says, on Earth, a spring stretches by 5.0 centimeter when a mass of 3.0 kilogram is suspended from one end. The gravitational field strength on the moon is 1/6 of that on the Earth. Which mass on the moon would stretch the spring by the same extension? So, first and foremost, we need to know the gravitational field strength on Earth. So, the extension is still the same. So, gravitational field strength on Earth is 9.8. So, doing that, it means 3 kilogram weight, 3 kilogram weight of 3 kilogram is mg. So that's 3 times 9.8 Newton per kilogram, and that will give us what? 29.2 Newton. So what we just need to know is this. This is the weight that produces this extension. So we want an equivalent weight on the moon, because let me show you, by the time you multiply this, the weight of this object on moon, the weight of that mass on moon will be 1.66 multiplied by 3, and that will give you 4.8 whatever. Can you see that? So it can produce the same extension on the moon. So we need an equivalent. We need this weight. So to have this weight on the moon now, what mass do we need? So we are going to do something like this. I'm going to say the weight I need to produce extension, because the spring constant of that spring is constant. You understand? It will still be 6 Newton per centimeter if you do the calculation. So what you just need to do here, don't stress yourself, this is the weight you need to always produce a 5 centimeter extension on the string. So what mass do you need? You are going to say, I need the weight, I need 29.2 on the moon to produce that extension. So, and I know weight is always equal to what? Mass multiplied by gravitational field strength. But this time it's going to be on moon. So what's gravitational field strength on moon? 9.8 divided by 6. So what will that give us? I think that should give us, okay, I do not want to stress myself so much like that. So let me just put it straight like this. 29.2 equals to the mass I'm looking for multiplied by 9.8 divided by 6. Is that okay? So then by the time I do this, my mass, therefore my mass will eventually be equals to 29.2 multiplied by 6 divided by 9.8, and that will give me 18 kilogram. So I need 18 kilogram mass to produce the same extension, 5 centimeter extension on the moon. So the answer is D. So let's go on. Okay, let's take question 5. A shopkeeper pours rice into a dish that hangs from a spring balance. He records the reading. You can see the reading. What's the reading here? This is 2.4 Newton. So let's go on. A customer buys some pasta. The shopkeeper notices that the reading on the spring balance with just pasta in the dish is the same as it was with just rice in the dish. What quantity must be the same for the rice and for the pasta? What quantity is the same? I'm using a spring balance. So a spring balance measures force, measures weight. So, and the weight of the pasta is the same as the weight of the rice. So we are measuring weight. So the answer is D. I hope this video has been helpful. To continue with the other part, watch my next video. The other part will be in my next video. Thank you. Do not forget to subscribe to my channel and give me a like the video, subscribe to the channel, and let's do the next video together. Then if you need me for personal tutor time, then send an email to oksolomon@gmail.com. So this is the email up here, oksolomon. Oh, you may not see that clearly. So let me put a text. Let me put it in a text box so you can see. So this is the email here. Yeah, that's the email. So you can contact me on that email anytime. If you have any question or you want further explanation,